The guided practice 3B from section 11.5, and we're finding the area under the curve, and so it's given us a definite integral. The first thing you need to do is figure out delta x, and remember delta x is b minus a over n, which is basically your start and end point. So in this case it's going to be 3 minus 0 over n, or 3 over n. Then you need to find x sub I, which is a plus I delta x. A is the starting point, so that's going to be 0. And then I delta x, you have I, and then your delta x is this one here, which is 3 over n. And that looks a bit funny, so we'll just rewrite it as 3i over n. Okay? Alright, once you have these two, then you need to go to your rule. So we'll rewrite the original question. So here we have x dx. And this equals the limit as n approaches infinity for the sum from I equals 1 to n of f of x sub I delta x. Okay, that's the rule. So here for f of x, I'm just going to kind of do this off to the side, but f of x is whatever your function is from the original question. So in this case, it's just x. Now, when I plug in x sub I, that means that I'm plugging this one into that function. So because it's just x, I'm just going to have x sub I. So this will be 3i over n. Alright, so now I'm ready to rewrite this as the limit as n approaches infinity. This sum from 1 to n. F of xi is this one, 3i over n. And then delta x is 3 over n. Okay, and as I demonstrated in the other one, basically what you can do is anything other than I, you just want to bring it out in front of the sum, because the I is the only thing changing. So in this case, I have 3 times 3, which will be 9, n times n, which will be n squared, and then I'll just have the sum of I. Okay, this you can look in your textbook, but really you need to memorize these. But basically this thing right here, I'm going to just kind of draw a circle around it. This thing, if you look in your textbook, it says that it equals n times n plus 1 over 2. Okay, so let's just expand that as we're looking at it. So it's n squared plus n over 2. So now I'm going to have the limit as n approaches infinity. I have 9 over n squared, and then this whole thing equals this thing. So n squared plus n over 2. So that's the limit as n approaches infinity. On the top you need to expand the 9, so 9n squared plus 9n. On the bottom 2n squared. And oh, just realized you couldn't see that, sorry about that. So at this point you're looking at limits of infinity, and we notice that we have the same power on the top and bottom, and from our investigation we know that if we have the same power on the top and bottom, that the limit will go to the leading coefficients. So in this case it will be equals 9 over 2. Now this kind of question, I recommend we check our answer in the calculator, because we learned that the calculator can actually do these for us. So I'm going to do alpha and then this bracket so that I can get an x, and in this case I'm going from 0 to 3. So that's the original question. And I just want to check. I got 9 halves here, I got 9 halves here, so I know my answer is correct.